The Zeroth Law of Thermodynamics is so named because it probably really should have been the first law of thermodynamics, but it was only realized that it was necessary after the existing first law, which we'll study in a future chapter, already was established. But this one should have been there before that, and again, they didn't want to rename that one, so they said, well, let's make it the zeroth law. In other words, we'll start counting at 0 instead of at 1. The idea of the zeroth law of thermodynamics is based on concepts of thermal contact and thermal equilibrium. In particular, thermal contact means that two objects are sufficiently connected so that heat can flow between them. And it turns out, we'll look in some more detail in the next chapter on how heat can flow in different ways. And it turns out that two objects can be in thermal contact without actually touching each other, as long as heat in some way can flow. And for example, one of the heat flow mechanisms is through radiation. So even at a distance, two objects could be in thermal contact with each other. Thermal equilibrium means that the net heat flow is 0. And it turns out that is what happens when two objects are at the same temperature. In other words, a slightly deeper definition of temperature is based on the idea that two objects are the same temperature when, if put into contact with each other, heat does not flow in one direction or another, or moreover, the net heat flow therefore is 0. I mean, we usually, the way we conceptualize, you could say there's always heat flowing, but when there's equal amounts flowing in both directions. So, for example, if I went over here and I've got objects A, B, and C, because it turns out, as you can see on the key concepts slide, that the zeroth law is stated in terms of kind of abstract objects A, B, and C. So let's say I wanted to put object A in contact with B. So one way I could do that, whoops, hopefully I'm going to get this selected correctly here, is I can just take this and move it over here and say, okay, they're going to sort of be touching each other. And so that would be one way of maybe symbolically saying they are in thermal contact, although, as I mentioned earlier, they don't necessarily in reality. There are different ways you could do that. Maybe I could even just put like some kind of heat conducting rod between the two of them, or I could even just have radiation passing between the two of them. In turn, I could also say, hey, what if like B and C are in thermal contact? Well, what the zeroth law is about is if B is in contact with A and I observe that there's no net heat flow, that would establish that A and B have the same temperature, right? And then if I took B and I said, okay, let's connect it with C, and there's also no heat flow, that would establish that B and C are at the same temperature. So of course, it would make sense that therefore if A is the same temperature as B and B is the same temperature as C, that A should be the same temperature as C. And naturally, if the basis for temperature is that when things are the same temperature, heat does not flow, that would mean that A and C, when put in contact with each other, so if instead I go over here and say, okay, let's take C and drag it over here and put it just barely maybe contacting A there, then if they're the same temperature, heat should also not flow. Now, if we look at the statement here on the key concepts slide, it says if object A is in thermal equilibrium with object B and B is in thermal equilibrium with object C, then A is in equilibrium with object C. And so for temperature to make sense, this has to be true about nature. If this were not true about nature, the idea of defining temperature based on heat not flowing between objects that have the same temperature wouldn't work.